Who's there? It's a fish to fry. Hey there, everybody. Welcome to episode number 498 of this here electronic engineering podcast called Amelia's Weekly Fish Fry. Brought to you by eejournal.com and written, produced, and hosted by yours truly, Amelia Dalton. Did you know that we are only 2 weeks away from the 500th episode of Amelia's Weekly Fish Fry? It's true. And this week, we highlighted one of the most important topics in all of electronic engineering: security. In this special playlist, I investigate a variety of critical security concerns, including the role that software fluency plays in automotive security, why software protection is more important than ever before, and the ethical nature of embedded security. And you can binge all 10 episodes of this special playlist by clicking the link below the player on this week's Fish Fryin' page on eejournal.com, by heading on over to our YouTube channel, youtube.com/eejournal, or by simply checking out the homepage of eejournal.com. Let's face it, the need for bandwidth isn't slowing down anytime soon. In this week's podcast, Raza Kahn from Semtech joins me to chat about the current state of 5G wireless infrastructure, the details of Semtech's new TriEdge solution aimed at next-generation data centers, and how the Open Eye MSA Group is helping accelerate the adoption of PAM4 optical data center interconnects. And also this week, I check out a new research project developed by a team from the University of Washington that opens up the possibility of 3D printing on Mars. But first, let's bring in Raza from Semtech. Hi, Raza. Thank you so much for joining me.
No problem, Amelia. Thank you for having me.
Okay, so we're talking about our ever-increasing need for bandwidth and the current state of 5G wireless infrastructure. So, Raza, before we check out some solutions, what do you see are the biggest challenges in this realm today?
Well, 5G is at a pretty interesting point overall, as I see it. One, there are heavy consumer expectations to enable what 5G had to promise initially. Those are all the cool things that people like myself are waiting for that have not yet been realized. Then the other main challenge is, in order for even to think about fulfilling those new use cases, how does the infrastructure upgrades and reimagining of the next 15 years of the backbone of that wireless infrastructure is put in place? So these two continue to be the key challenge, and many experts, the whole industry ecosystem is coming together with different views: C-band deployment, millimeter wave deployment. These are all just ways to kind of understand, to your question, how we address that ever increasing need for bandwidth. But really the core problem is, how do you lay the foundation for the next round of architecture upgrades in order to bring new use cases to reality?
That makes sense. Now, Semtech has a solution called TriEdge, which is aimed at this arena, right? Can you give us some details on TriEdge and what it brings to the table here?
Of course. So TriEdge is what we call is our proprietary technology to enable next generation of 5G upgrades. So TriEdge refers to 50 gig PAM4 optical links. That's where Semtech creates semiconductor devices that enable optical communication, optical fiber communication. So every time there's deployment, all these base stations and the 5G antenna towers, they're all interconnected with optical fiber. And the devices that Semtech makes live on each end of that fiber. So we enable that optical interconnected technology. And in order to really future-proof that upgrade. And as we were talking about the foundation of the infrastructure, that's what TriEdge is aiming to help with. We were very, very lucky and blessed that our team was able to really execute on the technology even during the pandemic, and we were able to bring it first to market. And we've been getting amazing traction with the ecosystem. And what we're enabling now is helping our customers adopt the TriEdge technology so they could have the next foundation in place. And that enables double the bandwidth of the current links, so 50 gig PAM4 at extremely low power, at ultra low latency, and a very good cost efficiency. And all these three are kind of interconnected. Without one, the 5G ecosystem doesn't really work. So you have to have power, cost, and latency advantage in order for any upgrades within the wireless architectures to be sustainable long term. And that's where the TriEdge technology completely hits it out of the park for all of those.
So Semtech also has a ClearEdge CDR portfolio as well, right? Can you explain the differences between ClearEdge and TriEdge?
Yeah, that's a great question. Typically, some of the keywords are in the name. So how we named it, ClearEdge was our proprietary technology to enable 25 gig links. And that's a simple modulation. So when we call 25 gigabits per second links or bandwidth for the optical fiber, that was based on NRZ technology. Now with TriEdge, there's advanced modulation called PAM4, but it essentially doubles the bandwidth to 50 gig effectively. So ClearEdge is our technology to enable 25 gig links on the fiber, and TriEdge is our proprietary technology to enable 50 gig PAM4 optical links. Both technologies have their spaces within the ecosystem. We were talking about that foundation of 5G, and it is not one solution fits all, how it was in 4G. 5G is very diverse, and you can have a multitude of different architectures by regional requirements, by carrier needs, by government mandates. There's a lot of aspects that come together to really create a 5G web that enables all the interconnected applications. So ClearEdge is still seen as one of the great ways to enable C-band deployment, which is now the US is going mainstream with, and we're really taking good traction there. And TriEdge is really setting up the whole ecosystem to adopt the technology to serve the next 15 years. So TriEdge is really aimed at enabling future proofing, also enabling millimeter wave, and that will serve as the basis of the new applications like metaverse, autonomous cars, virtual reality, and all kinds of other things that we haven't seen yet. Whereas the ClearEdge portfolio still has a very solid base to enable the current C-band deployments.
So, Raza, Semtech is a founding member of the Open Eye MSA. So, tell me more about this consortium and its goals and Semtech's role in this consortium.
Yes, so when Semtech, as a founding member of the Open Eye MSA, the objective was to help the ecosystem adopt a new technology. When TriEdge was introduced by Semtech, we also wanted to provide our customers and their customers an easier way to look at how good their optical links might be. And there's different standards out there that do the same aspect. They all try to help other customers understand how good the link truly is and how much margin there is in the link. Because if you can judge that, that's the whole idea, to be able to understand if you had sent a 1 or a 0, it needs to be understood as a 1 or 0 on the other end of the fiber. That's all it is. So these are all different kinds of metrics that the industry has come up with to be able to easily help our customers and their customers understand the margin in the optical links. And OpenEye MSA is part of that vision. Because TriEdge was really a disruptive technology, it had some clear benefits. OpenEye MSA was really introduced to allow customers with an alternative metric methodology to be able to understand how much margin there could be in the links. And that's where we're still seeing quite a bit of traction with our customers to adopt the OpenEye methodology of understanding the link, but also there's IEEE, which has metrics. So overall, our aim is to basically create innovative ICs that help our customers deploy next generation technology, but also help them save cost and power. And the standards like IEEE and OpenEye MSA just serve a means to an easier adoption of new technologies.
Excellent, Raza. I think it's time for your off the cuff question now. Now, since you haven't been on my show before, you get the standard off the cuff. So, Raza, a lot of us can't have our favorite foods these days for one reason or another, whether it's lockdown, the lack of travel, the restaurants closed. So, if you could have one meal right now, what would it be?
In a way, it's an easier question, but I would answer it in a complex way just because I haven't been on the show before. What I would say is that I've had a major change in my diet and how I've looked at food and nutrition over the pandemic. So I'm going to say before pandemic, my answer would have been very different. During the pandemic, I adopted more of a vegetarian diet. I went almost vegan for about 8 months. I experimented with that, how it would affect my mood, my mental wellness aspect, my health. So I became a lot more focused on that. And I've been very lucky and blessed again that I got into cooking again. So it really drove a passion of mine to cook food, fresh ingredients, and cook something. So to answer your question, now if I crave something, it's the simple foods that I can have the time to make fresh. And that could be any easy vegetarian meal that I can cook. And I've really learned to enjoy jackfruit in more ways than I thought was possible before I tried the vegetarian diet. So I think that would be my complex answer to your simple question.
I love it. And I too have been leaning toward that these days as well. It's funny how it changes a lot of things in your life.
It is. Life is a strange adventure that we all must travel on.
Excellent. Well, Raza, this has been super cool. Thank you so much for joining me.
My pleasure, my pleasure. Thank you so much for having me, Amelia.
Here on Fish Fry, I love a good 3D printing story. And I absolutely love anything that has to do with space. And this next story is a perfect combination of the two. So, what if we could use Mars soil to 3D print tools and building supplies? Well, my friends, this could actually be a possibility. So, using an artificial substance designed to mimic the regolith found on Mars, mixed with a titanium alloy, a team of researchers from the University of Washington were able to 3D print both tools and building materials. So, how exactly did they do this? First, they heated a mixture of these two materials to 2000 degrees Celsius. Then this metal material flowed onto a moving platform that allowed the researchers to create different shapes and sizes. And when it cooled, it formed a ceramic material. Very interestingly, the amount of Mars regolith in the mixture made a big difference in the durability of the material. When they used 100% Mars regolith, the components cracked when they cooled and wore out very quickly during their durability tests. Even though this percentage of regolith isn't great for building materials or tools, this team does contend that it could still be used as a coating against radiation. The sweet spot for the amount of regolith in this mixture was around 5%. With that amount of regolith, it cooled just fine without bubbling or cracking and performed better than the titanium alloy alone. Professor at the WSU School of Mechanical and Materials Engineering, Amit Bandyopadhyay, one of the authors of this study, explains the ramifications of this research like this. He says, "This establishes that it is possible, and maybe we should think in this direction, because it's not just making plastic parts which are weak, but metal ceramic composite parts which are strong and can be used for any kind of structural parts." So, is this technology ready for prime time? Well, no, not quite yet. But it is a huge step forward for manned missions to Mars. Next, this team is planning on experimenting with other metals and different 3D printing techniques. So, if you want even more information or to check out a video about the potential of 3D printing on Mars, I've included a couple links below the player on this week's Fish Frying page on eejournal.com. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EEJournal. If you're into Twitter, you can monitor our tweets at EEJournalTFM. And don't forget, if you would like to follow my personal Twitter account, check out Amelia D 1978. And hey, if LinkedIn is more your thing, sure, I dig it. You can follow us or me on LinkedIn as well. And we have that YouTube channel I mentioned earlier, youtube.com/EEJournal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series, hosted by me, and those select fish fry playlists as well. Also, by clicking the links below the player on this week's Fish Frying page, you can subscribe to this here podcast through Spotify, Podbean, or Apple Podcasts. And remember, if you'd like to further support this podcast, please leave me a review on that podcasting platform of your choice. It really does help. Also, if you'd like any further information about the stories covered in today's show, just head on over to eejournal.com and look for this week's Fish Frying page. Thank you everyone for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's AMELIA, at eejournal.com, or post a comment on our forums on EEJournal. For the week of September 9th, 2022, I'm Amelia Dalton. You've been fried.